My name is Scott Buchholz. It's nice to see all of you here today. I have the privilege of being the Chief Technology Officer for our federal government consulting practice. In that regard, what my job is to help bring innovation and technology to our clients and to our project teams. If you have a problem with your laptop, that's somebody else's problem. You don't need to call me. With me here on stage today, I have Ashish Varan. Ashish is one of Deloitte's senior cloud architects. We unfortunately weren't able to have on stage with us today the other two key players in the journey with us from the client side. Scott Henderson, who is the Amtrak chief architect for the program and in general, has retired since the system went live, so he's enjoying some well-deserved rest. Steve Lebo, who is the day-to-day architect and very experienced with AWS. In fact, some of the AWS solution architects like to tell us that it was either really great or really awful working with Steve, because Steve tended to know as much as they did about a lot of their stuff, and so that was sometimes an interesting series of discussions. But Steve was instrumental in helping design the system, get it to where it was, and take it forward. Unfortunately, he had a personal conflict today, but we did want to honor his contribution to this process before we got started. So, with that, a little bit about Amtrak. So, those of us who live on the East Coast, and probably some of the rest of you are familiar with Amtrak. I don't know that everybody is. It's not such a thing sometimes in the Midwest and the West Coast. Amtrak is actually the nation's passenger rail carrier. They are a partially government-funded organization, a little bit like the post office, although they are largely a commercial entity. As you can see, between DC and Boston, which we consider the Northeast Corridor, they actually carry more passengers every year than airplanes. And in fact, there are a lot of things about Amtrak that are really great, and what I'll say is for those of us who live in DC, it really is one of the best ways of getting up and down the East Coast. I don't know if you've seen the traffic on I-95, if any of you live in that area, but it is not worth venturing forth on if you can avoid it. So Amtrak's a really great alternative for those of you who are curious. The system that we're talking about today, we sometimes call the data hub or the sales data hub, was actually, it doesn't sound like much, but it actually is one of the mission critical components of running Amtrak. What winds up happening is Amtrak, like airlines, needs to know who they have on their trains. And so sort of like airlines, Amtrak needs to figure it out. The challenge is, unlike airplanes where, as we all know, you get on and everybody gets on at the same time and everybody gets off at the same time, for a train, the train goes through quite a few stations on the way from its start to its destination, and people get on and off all the time. So while they have the same kinds of capacity planning issues and supply issues, while they have the same kinds of requirements around knowing who's on the vehicle in the event of an emergency, they have a lot more logistical problems than most airlines do in terms of figuring out who's actually on the train at any given point in time. It's complicated somewhat by the fact that you can actually just walk onto an Amtrak train in most cases and buy a ticket in real time, which actually makes it even harder to keep track of basically what's going on the train. This system, in part, helps both the operational teams know who's on the trains and how many passengers and what their names are. It also helps the sales and marketing team know how much revenue has been generated and what the projections look like, what going forward looks like, and manage their business from a revenue and collections perspective. And so one of the things I'll sort of talk a little bit about just briefly so that you understand is the system actually manages two key constructs. One of them is bookings and one of them is tickets. So booking is basically a holder, right? It's a container for tickets. It's probably the easiest way to think of it. And if you make a booking, you can add multiple tickets to it. If you and your family are traveling, you can have one or more tickets associated with it. And those tickets actually have start, destination, and person associated with them. It gets much more interesting, though. Because on the train, unlike on an airplane, right, where you still have bookings and tickets, you can buy a booklet of tickets. You can buy 10 trips from A to B, and you can use them at any point in time you want. Amtrak doesn't get to sort of know in advance you're going to use them. So you can have complex sort of ticket arrangements. You can also have tickets without bookings. Because if you're an employee, you're allowed to just walk onto the train and give them your badge, and suddenly you have a ticket, you're on the train, but there was no booking that was made. And so what winds up happening is their job of knowing who's on the train based on bookings and tickets is actually really quite complex. And in addition, tickets go through a life cycle. So they go from purchased and printed and all sorts of other things to actually lifted. And so just for those of you who care about such things, Amtrak can't actually recognize the revenue from your ticket until you've actually traveled on the train. So it's very important that they lift your ticket, or basically recognize that you're on the train. That enables them to do a couple of different things. One is recognize who's on the train and where you're getting on and off. And the second one is actually to be able to make money. One of the other things about Amtrak that's just important to know as we go through this is that all of this stuff is managed by their mainframe system. So they have a mainframe system based on Sabre, highly customized. Sabre's the thing that runs the airline industry, yeah. And basically what winds up happening is it's very difficult to get information in and out of that system in real time because it was designed to be a transactional system. And as a result, systems like the Data Hub actually enable the ability to do queries in operations and for analytics. So that's sort of a brief overview, and hopefully that made sense. When we got to Amtrak, they had some existing systems, a couple of them actually, that were trying to solve the problems that the Data Hub has been resolving. So the systems, as I talked about, were managing bookings, and they were managing tickets. They were actually doing it separately. They were trying to enable reporting on both. Some of the reporting was for sales and marketing. Some of the reporting was for operations. And a lot of the challenges that they wound up having, you could see up here, the query time for some of the legacy systems was unpredictable. If you think about it, that's not such a big deal if you're running an analytical query. It is a big deal if you're trying to figure out who's on the train during an emergency. And there were times when the queries could take a few seconds, and every once in a while, they took several minutes or an hour. Nobody could really quite figure out why, but lots of people spent time admiring the problem and scratching their heads and thinking about it. From a business perspective, when they got reports, when the sales and marketing team got reports, they were usually at least 24 hours old, and they were relatively limited in terms of what they were able to do. Data was copied all over everywhere, right? We all love copying data because everybody likes to have their copy of the data, right? So they did that. Lots of people had copies of data. Some of it even matched. What was even more fun was it was not just a tightly coupled system in terms of technology, but it was a tightly coupled system the way the business users used it. Because the business users figured out that they could actually join tables across several different databases together, and they would do so to produce these really crazy reports, and it drove the IT team nuts, because every time they tried to change something, guess what? They would get a call from the business, hey, you broke my report. And they would say, what report? What the hell are you doing, right? So it was, and it was a journey, all right? And then the existing systems were not exactly quick to be able to update and maintain. We were asked to come in and do a solution, basically an assessment of what was going on, and try to figure out what it was that we could do. So we were working with Scott and Steve, the two architects I talked about earlier, to try to figure out what to do with one of the legacy systems, which was called the Sales ODS. They had a number of guiding principles. You can see them up here, but they wanted to get away from the challenges. They wanted to have responsive, high response times from an operational perspective. They wanted to be able to get sales and marketing their data in as close to real time as they could. They wanted better agility in the ability to actually make changes. They wanted to prove that things could happen fast. They were tired of managing servers, and so we had sort of this parenthetical, if we could get out of that business, that would be great, construct too. And they were trying to lower costs. The existing systems cost quite a bit to run and maintain, And that was a bit of a problem. So we were asked to do an assessment. I and Ashish actually led the assessment. So Ashish, do you want to talk a little bit about it?
Sure. Hello, everyone. So how many of you have a serverless workload in production? How many of you have DynamoDB in production? OK. So as Scott said, when we started the assessment, the first 2 weeks were very interesting. After the kickoff, we are in this meeting where we are working with DBAs and chief architects, and they go, Ashish, we have this huge data model that we are building for last 6 months. Can you help us complete and implement it? So this was a relational data model, logical, that they were working on. And I was like, wait, OK, so what are your use cases? They said, well, we have 2 legacy systems with sales data, booking, and tickets. We want to bring them together, and we want to do a lot of analytics on it, real-time reporting on it. We want to, what else? So we want to send real-time marketing campaigns based on the data we receive from our mainframe systems. We want to do fraud detection. You name it, we want to do everything. And by the way, we have a huge program running in parallel that's going to go for 5 years, and we want to be the upstream or feeder system for that program. So it was a complex problem to solve. And we said, well, with complexity, can we wait? Let's wait a couple of minutes. Can we take a step back and think differently? Can we think about a different approach? Can we use so let's think about using NoSQL database to solve what you're trying to do. There was a lot of uneasiness because, like many organizations, and we were doing this a year and a half back, they had no experience working with NoSQL databases. AWS, there was no serverless architecture or anything in production. So they were worried about O&M processes, how we are going to do this. So what really helped us from the 2 things that helped us. One is we had a buy-in from their chief architects and directors, Scott and Steve. So that helped us determine or establish guiding principles. We want no servers. We want to reduce the operational cost. We don't want any O&M. So that was helpful for us to get to a solution. But our bigger challenge was that, OK, even if we do NoSQL data and we build it following the serverless architecture principles, how do we convince business that this is going to work? And to solve that, we started building a set of prototypes. We were in a situation where we didn't have access to AWS. So we selected a mean stack to build a couple of prototypes. We were able to get the transaction payloads, all variations of it, merge the data, build a file, store it in the database, and build services on top of it. And we did that, and we were able to show in about 3 weeks that this is easy. You can merge the data, you can run the queries, you can run the reports, you can build the data services. So that, working along with client and building prototypes, showing them the art of the possible, helped us finalize the go-forward direction. And they were able to, and the decision was, OK, let's pause relational modeling. Let's not do that. Let's try to solve this using a set of NoSQL and serverless frameworks. Scott?
Sure. I'm going to apologize because I realize Ashish asked how many people sort of know the basics. So at least half the room knows the basics. So this is for the other half of the room. Thank you for your patience. If you look at this picture, right, what we have is a little bit of a progression over time. So many of us, those of us who are old enough, right, remember the days of physical machines. Does anybody remember having the server sitting under their desk for the production system? Some of us do. You know, gone are those days. And I don't know that I miss them, but certainly they were fun because I could break production just by kicking the wrong thing. Maybe that's a good thing. I don't know. But over time, what we've done is we've moved up the levels of abstraction, right? So we've moved from managing physical things to managing virtual things and gained a lot in that regard, right? So by moving from the physical to the virtual, the time to do things in a virtual environment can be measured sometimes in days and minutes, right? And doing things in the physical environment when you needed a new server took weeks or months, takes 9 to 12 months with some of our clients in the federal government because that's fast. So anyway, so if you move out of the physical environment, you move into the virtual environment. Since then, we've also discovered containers, which simplifies managing the virtual things. I've had the privilege of doing server administration over the years. I don't miss doing that either, right? And so you move into containers where you're doing less of the actual machine administration and the server administration. You're moving into higher levels of abstraction. It makes a number of other things easier. It makes a lot of things go faster. Serverless is sort of the next logical thing, right? As I tell people, if you think about it, right, serverless is not that there's no server, it's that we don't have to manage it anymore. And I spent many years as a developer. I've worked with a lot of infrastructure organizations over the years. I'm not going to lie, I don't miss managing hardware. I don't miss managing hardware configurations. I don't miss arguing with the server administrators over whether or not they got that script right or not. I don't miss any of that stuff. The other really great thing that I don't miss, which is not necessarily as obvious just looking at the picture, is if you think about how we sized things in the past, right? People come to us and they go, well, how big of a database do we need? Because we have to go buy some physical hardware, right? And we'd go, we need a big one. How do we tell them we need a big one, right? Just in case, because we don't really know, but we kind of think we need a big one. So we're gonna come up with some numbers and we're gonna estimate size, right? And then once we have a bunch of numbers that seem like they mean something, we apply a fudge factor, because you never know, right? And then you take it to the database company and you say, hey, we have a system, we're gonna have 1 million transactions, how big a database do they need? And they go and they look up on their chart and they tell you how big a system you need. Of course, their chart's got a fudge factor built in too, right? Because they're no dummies. They know that people are underestimating things all the time. And so we wind up invariably with a whole lot of hardware that just sits around and contributes to global warming most of the time. Right, so if you think about it, what is it that most of our servers in production are doing most of the time? The answer is nothing. They're just heating the air in the data center. And as a result, one of the things, if you actually look at the average utilization of most servers in data centers, it's actually incredibly low. Which is part of the reason why AWS and the others can do virtualization and do it so cheaply, is because they take advantage of that fact. But the funny thing is, if you have to pay for the privilege of a server, virtual or otherwise, which you are not using most of the time, it costs you significantly more than if you're just paying as you use it. And so what actually winds up happening, we've got a couple of utilization cost figures a little bit later on, but it turns out that in most cases, the cost of actually doing something in a serverless way is dramatically less than doing it in a sort of server-based construct, because you pay for what you use, and what you use most of the time is a tiny fraction of the actual capacity of a server. And the cloud providers of the world have figured this out, and they charge you accordingly, right? So it's actually been a wonderful journey. The other thing, actually, too, that I'll point out about serverless that I hadn't really thought that hard about until one of our team members came and beat me over the head about it, because he showed me a picture, is that if you think about how we did dev and test in production environments in the past, dev was a skinny down version of production, right? Test is a slightly less skinny down version. If you're lucky, you got a staging environment that has half of production, and production was production, right? In a serverless world, your environments actually look exactly the same. They look exactly the same. They behave the same way. They've got the same components. They've got the same configurations. They're the same. The only difference is because you're paying for what you use, it's a fraction of the cost to run dev than it is to run test and production. But you don't have this sort of mystery factor that when you scale things up, it breaks. And you can test dev at scale if you need to, right? So you don't have to go out and buy a huge dev environment just to do scalability testing. You can just do it, and then if you want, you can dial it back. And to me, that was kind of like one of those moments where I went, oh, maybe there is something here. So that's just a little bit about serverless. Thank you for those who already knew this. You going to do this one? No. OK. All right. So I've been talking for a little while. Suitable use cases, things on the left, right? So the ones in orange were actually the cases we were dealing with. We had web applications. We had RESTful services. It's helpful if you're doing short things, helpful if you're doing analytics, helpful if you're doing real-time, mobile, IoT, those kinds of things, right? Because you don't have to provision and save a whole lot of stuff. If you're on the right-hand side and you have things where you need a command line, where you need a lot of memory, where it's going to take a long time, those things are sometimes less well-suited for serverless use cases. So now what's going to happen is I'm going to turn it over to Ashish, and he's going to tell you some more of the technical details about what it was that we did and how we got there. So, Mr. Varin.
So after the assessment, our job was to build the solution. And given that we had a guiding principle to not to use servers, there was to reduce the cost. There is no need to over or under provision. We started to pick our components to solve this problem. In AWS ecosystem, that's the Lambda. It's a function as a service. You pay when you use it, otherwise you don't have to do anything. We needed a place to store transactional data coming out from IBM mainframe, their transaction processing facility, all the reservation and ticket data. So we chose DynamoDB. Again, no server, or nothing to maintain. And for for warehouse reporting, in AWS ecosystem, we picked up Redshift. We looked at a couple of options, but given the volume of data, and we needed to migrate 5 years worth of billions of record from legacy systems, we picked up Redshift because during a couple of quick POCs and stats suggested that given that it is a columnar database, it's going to perform very well for reporting. To glue everything, we had data pipeline, Kinesis. You will see that on the next slide. We needed to parallel process our transactions, so Kinesis was a good fit for us. We had S3 to move data around, to store our data, to have a copy of the data that we can work later on, to export and import data, and SNS to send notifications in case of something failed, something didn't work. And there were some other components. Let's go to the next slide to see how all of this came together to solve the problem at hand. So what you see up here is a simplified view of our architecture. And when I say simplified, we have removed a few components to keep the conversation focused. On the left, you have legacy and IBM mainframe systems. So these are transaction processing facilities for reservations and booking. And on the left, you will also notice there are two databases. There are Oracle racks running, collecting data from the mainframe. So on the right of this diagram, you have all the downstream systems, so operations, who is on the train, where the trains are, how many passengers are traveling, notifications, your train is delayed, or you kind of send updated itinerary, travel alerts, everything, passenger manifest. So a lot of mission-critical systems on the right. Revenue accounting systems on the right. You are making a sale. When the passenger is traveling, you lift the ticket. Now your liability becomes an asset. It is a revenue recognizing event the moment you board the train, and your ticket gets scanned. Your trade partners who are trying to sell tickets on their portal, they are all accessing the same data through data services. So in the middle is what we built. Now, you will notice that there are multiple services on it, but on the top, what you see is the core of the data flow or data frameworks that we made. So there are DynamoDB's tables that collect all the booking and ticket data. We used to move data around. We used Kinesis and Lambda and Kinesis, and a combination of streaming services to move data, merge data, consolidate, and cleanse the data. And through a set of services, we had MuleSoft Cloud of Services. We kind of provisioned the data for our clients. Glacier and as was used to archive the data, so we had rule-based archiving. After 7 days, we kind of took the data out from DynamoDB. To move the data to Redshift, we had a set of Lambda functions that put the data on data pipeline, and from there, we moved the data to Redshift. Monitoring was done using AppDynamics. AppDynamics provides out-of-box capabilities to read the metrics from CloudWatch. And we built, and we will discuss more about it on the next slide, we built our custom logging to capture business events or error. It was not a great idea, but we did that. And again, through a Lambda, we kind of sent the notifications to email to tier 1, tier 2, tier 3 help people. So I can probably spend an hour talking about lessons learned. There are many. So when you start, for us, I think the critical part to build a serverless is you got to know what services are you using and how are you going to configure those services, what are the limitations or benefits of using those services. So I will give you a couple of examples. For DynamoDB, when we started using it, it allows 5 primary and secondary indexes. So you have to choose your indexes carefully. There is a key design where you have to design hash key and sort key. Given that we had a time series data, we use timestamps in microsecond for our sort keys. There is a limit of 400 KB for your record. So you have to design a combination of column names and the strategies that you want to implement to handle data payloads where the size is more than 400 KB. I mean, 400 KB is a lot of data, to be honest, but there were scenarios where we ran into situations where the data size was more than 400 kilobytes. For Kinesis, you have to have optimized so the way Kinesis stores the data, it stores the data in shards. So you have to optimize number of shards you have so that you don't, because there is a timeout period of, I think, 168 hours. So you want to process the data and move the data out from your Kinesis streams to a more persistent storage. The longest pole in our architecture, or where we spent most of our time, was data migration. We have to migrate 5 years worth of data, multi-million records. We did a lot of POCs to move data from a relational database to a non-relational database. We tried third-party plugins. We started with that. It didn't work out for us. We used tier 1 adapters to move the data. That didn't work out for us because our JSON transformations were complex. Our level 2, level 3 data elements in our target files were very complex. So out of the box, third-party market products, they couldn't do it. So we have to break the problem in 2 parts. We took the data out from relational database and moved it to S3. I mean, that was kind of a flat file. And then we wrote custom MuleSoft jobs or routines to load data back to DynamoDB. When all of this was ready and when we started running it, the things started timing out, or we saw a lot of throttling. So the key idea here is that plan your data migration and set aside time to do that work. It's easy to build that, the core architecture end to end. So you have to, for example, you have to change your read and write capacities to load the data. Now that can incur a lot of costs. So once you are done with the migration, you need to reset read and write capacities, or things like that. For logging and archiving, as I said, we created a custom DynamoDB table to capture some of the business errors or data errors. That was not a great idea. In the retrospect, we think we could have used a framework EFK to do it, consolidate, and in a consolidated way. Scott, you want to talk about it?
Sure. And then last but not least, one of the things we learned and realized, so I've been around for a long time. I get accused of being a curmudgeon sometimes by some of my teams. But one of the things that I used to work on was two-phase distributed commit protocols for databases. Sounds very exciting. It's basically what makes sure that when you go to the ATM that you get the cash and your account gets debited at the same time, and you don't actually either get the cash or get your account debited and not the other. That's sort of what it's for. If you think a little bit about the system as we were talking about it, one of the things that's really important is that no data is lost. That could either be not knowing people who are on the train, which is a problem in an emergency, or not being able to account for revenue, which is a different kind of emergency for the CFO's organization. And one of the things that we actually found out was we spent a bunch of time trying to make sure that we didn't have any points where we were going to lose data. What we actually discovered was we didn't have any problems getting data into the operational side of the system, but we were counting on, inadvertently, service availability to get data out of the operational store into the reporting store for analytics. So back in earlier this year, we discovered that was a thing and actually wound up having to fix it. So as Ashish said, we had a lot of lessons learned throughout the process, and are more than happy to talk about them at length, ad nauseum. This system that we're talking about was built in about 6 months, right? So we went from concept to production in about 6 months. It probably would have been slightly less, but there were a few infrastructure challenges in our way in the holidays, and for some reason, people who have high volumes in holidays don't like changing their operational systems in midstream. I don't know why. No sense of adventure. So the system currently processes about 1 million transactions a day. As I sometimes tell people, it is fully buzzword compliant, right? So we've got RESTful services and JSON and serverless and all the buzzwords you want. It has been up without a problem since January, right? We actually have Tableau, so you can see a couple of the Tableau dashboards down at the bottom. That's wonderful because, as many of you know, business users really like pretty pictures, so we are also pretty picture compliant. I'll show you one of the pretty pictures on the next slide. And it is actually serving as the next generation platform for a lot of what they're doing. There is a project that's been built on top of the Data Hub, as I think Ashish mentioned earlier, which is doing essentially upsell marketing. So if you are a frequent traveler on Amtrak and you're registered with them and your cell phone is registered with them, you are one of the 1 million cell phones that's currently been registered in the system. If you are one of the about a third of those people who's accepted offers from Amtrak at some point in the next calendar year, you will be able to get automated notifications on your phone coming through SNS in order to basically get offers to upsell you, right? So if you're riding in business class, it's an offer to ride in first class at a reduced price shortly before the train takes off. That helps revenue, that helps capacity management. It does all sorts of good things from Amtrak's point of view. They're also in the process of migrating the revenue accounting pieces that are not currently in the system to the system so that they can start doing revenue recognition out of the system. So there are a lot of things that are currently going on. This was phase 1, and they're currently on phase 2 or 3 or whatever, depending on how you count, but it is very much that the system is becoming central to a lot of what they're doing. On the right, you can see some of the costs for running the system. All I can say is it's significantly less than the legacy systems that they were running in terms of production infrastructure costs and licensing costs. And it also, by the way, the first time I saw these numbers, I told the guys they were missing some zeros, like they'd screwed up and they needed to go back and look at the console. But it really is an artifact of the fact that we're all accustomed, some of us, those of us who've been around a while are all accustomed to seeing costs that are about reserving lots of capacity for long periods of time, and this is suddenly not that anymore, right? Pay for what you use. Here is one of our spiffy-looking dashboards, right? For those of you familiar with Tableau, Tableau is a wonderful product. This kind of stuff comes out of the box. I'm supposed to remember the name of this chart. Sankey? Sankey, yeah, whatever. Pretty picture. So what it basically is it's a flow diagram, and what it allows you to do, particularly as a business user, is it allows you to see the relationship between different elements. So it's probably an art chart from where all of you sit, but what you've got is travel class, route, age demographic group, and booking source. And so you can actually trace through and move the columns around to basically try to understand demographic information, who's traveling on your trains, how are they booking, where are they booking, what kinds of routes are they booking, sort of all sorts of interesting information. And this is just one of the many dashboards that we put together to help the sales and marketing team. All right, so in conclusion, right, rapid delivery start to finish, right? In about 6 months, we went from having no system to operational system being live. It's gone through stress testing, basically through peak reservation periods, which happen, by the way, right about now, among other things. It's gone through them, it's sailed through them, it's humming along, it's almost boring to watch it go. It's helped take operational report generation from unpredictable timelines down to sub-second, right? It's taken analytics from maybe you'll get your report within 24 hours, or maybe you can ask somebody to go run it for you, to being able to go do self-service dashboards with significantly more advanced functionality than was available previously. We've consolidated data into one place, so it's not sort of running around all over everywhere anymore. We've taken the loose coupling out of the systems. We've done it and made it set up very quickly, and we've set up, as I talked about, the platform for the future that they're currently leveraging as they move forward to increasingly add functionality and the ability to do more advanced analytics and a number of other use cases like, I don't know that they'll get to fraud detection with it, but perhaps they will at some point. But there are a lot of other things that can certainly be done with the information and the data that we have. So with that, we conclude and ask, are there any questions? Sure.
If any challenges you ran into in maintaining this when you went to production initially, given probably the inexperience, we're kind of doing the same thing.
Sure. So the question, I don't know if people could hear it, was were there any challenges basically going to production because a lot of the people who needed to do the operations and maintenance weren't necessarily familiar with the architecture? So Ashish, you want to?
Yeah, sure. So given that this was first production rollout, we have to work with production support team to create SOPs. So we created those, So that was a combination of roles and responsibility. And how do you do basic housekeeping? If you have to archive the data, let's say, how do you operate on Glacier? basic housekeeping. I mean, we ran this in production-like setup, given that's a big advantage because you are not buying excess capacity in a stage for 2 months without them doing anything. So for them, it was like, are we going to do anything on this when we go live, or it's just going to run? And our point was, as long as your mainframe TPFs are running and AWS and the connectivity is there, it's just going to run. In odd scenarios, you have to do a basic settings or change your read and write capacities if you see something on App Dynamics monitoring. So we had those thresholds configured. Having a central dashboard in App Dynamics helped because you can see the way we configured it. We had your mule data services, all AWS services, all metrics except data pipeline, and your upstream metrics coming out from IBM MQ and JBoss were all at one place. So you can see end-to-end flow of the data and metrics at one place. So those were the controls and processes we put in place to make the O&M team comfortable, and they gave us a go-ahead.
I'm not sure which hand went up there. Sir?
Yeah, I have a question about the Lambda. My understanding about the Lambda is fairly limited, our experience with that. Can you elaborate on some of the challenges in terms of implementing the business logic, but also somehow have some references in terms of comparison to other kind of languages such as Python, Java, or C++. My engineers keeps telling me that Lambda is very limited.
Okay.
Do you want to repeat the question?
Yes. So the question was that, can you elaborate how Lambda work? And the question was, what was our experience working with Lambda? Are there limitations, and how different languages, how can you use different languages to write Lambda functions? So Lambda truly is a function, correct? So you have to run a piece of code, you write in Lambda, it runs, it gets the work done. There are multiple triggers that you can attach your Lambda functions to. For example, if you insert a record in DynamoDB, it works like an update insert after trigger. The lifespan, there is a fixed lifespan to run your Lambda function, so you need to optimize, let's say if it is 3 minutes. You need to make sure that the job that you are trying to process ends in 3 minutes. Now, if you end your job in 10 seconds, it's going to cost you more money, so you need to optimize your Lambda functions. I think the practical challenges we had is, how do we test Lambda? So you have to, or how do you version control your Lambda functions? So in our DevOps pipeline, if we make a code change in dev and your stage has different version of Lambda functions running, you have to do versioning. Otherwise, given the set of services that can connect to Lambda, it's a pretty powerful compute engine in AWS.
Here's something I might add, actually, is that if you're thinking about how to build a Lambda function in the same way that we used to think about how to build a servlet, then you're probably going to get yourself a little bit sideways, right? So some of this really is, how much business logic do you put in small functions, and how much do you string them together? How much can you make it more about microservices and small transactions as opposed to big ones? And it really is in many ways a mental shift. And not everybody always embraces change. So, sorry. Yeah.
Can you say a little bit more about what the mistakes you were mentioning were around the monitoring and logging?
Yes. So we created a DynamoDB table to log our error messages, without realizing that if you get a large amount of bad data, the interface to DynamoDB is not going to allow you to get to the message you want to get to. So you have like thousands of records. Now, how do I get to the right error message, correct? So when you are in dev mode, you have a happy path. But in production, if things go wrong and you have to get to the message that you need to see quickly, we kind of rushed it, and and it was not the best solution. And the reason was, in parallel, Amtrak was also building EFK framework. So we kind of two projects were running in parallel, so we couldn't use it. So now we are in the process of tying it back to EFK framework so that the log is consolidated at a center place, can be in Kibana.
So in a nutshell, we rolled our own logging, and in retrospect, we wished we had just used what Amazon provided. But it sort of seemed like the right thing to do at the time. Sorry, I want to make sure I didn't miss hands over here. Ma'am? How are we planning to roll out updates?
So we covered it briefly. We will build a DevOps pipeline to deploy our code. We used the DevOps pipeline heavily use CLI functions to roll out. And the beauty of serverless deployment is that your components are disconnected. So if we have to update a Lambda function, then we are going to just update that Lambda function. You can update while the function is running, or you can, because we have, in this case, we had a message queue upstream, you can take the system, you can shut down or deploy a new Lambda function, and your message can accumulate on the queue, and then you open the queue again to get the data flowing back to AWS.
Sure.
What kind of code did you write to manage AWS resources? Maybe something like scaling, resharding, and how much code is it?
So for scaling, we didn't write any code. It was all configurations. For sharding, for Kinesis, when we started running heavy production workloads, we saw throttling at many levels on DynamoDB. So we have to adjust the read and write capacities. And then the data was sitting on the shards for a very long time. So we have to adjust the number of shards to get the data in the operational DynamoDB databases and out to Redshift. And then we reset those production workload, those settings for production, because I think our read capacity is 3 for 1 million transactions. It was not a lot. So to answer your question, we didn't write code. It was just all configuration setting and running the workload and adjusting and getting to the optimal throughput.
I know there was a question over here. The question was basically, as we did the migration, did we reuse the old code? And essentially, the answer is no. As it turns out, the legacy systems were relational. And there was, they were relational, we were moving to non-relational. So we looked at them to see sort of what they were doing and how they were doing it, but we did not try to reuse what they had done.
Basically, you take the relational data and move it to a text file, and then you pick up that text file through ML services to load the data.
Yeah, although actually, I shouldn't say, I should be a little bit more specific. There was some of the information that was reused. So if you look at the way the architecture is set up, there are actually services that are basically doing the dequeuing of the events from the mainframe. To be fair, that was reused, right? Now, what happened after we got stuff off the mainframe, that was new. Basically, from there forward. So.
You guys run into any security or compliance issues moving this type of data into a cloud environment, or just
Yes, so let me answer. So with DynamoDB, because it is out there, you have to, in AWS IAM, you have to have very specific permissions to lock down your production tables. You have to give resource level access to certain IDs to lock down your production tables and make sure that they are different. Because otherwise your developers can drop production tables, to be honest. The second challenge for us was, how do we, because we are putting data on the cloud, how do we encrypt the data, right? There was PII, person name, address, phone numbers. So we encrypted on the fly. The data was encrypted before we even posted to AWS, and it stayed encrypted. We decrypted the data when we moved it out to Redshift, or when a data service called, like direct call to DynamoDB to get the data. So we encrypted when there was a ask for the data. So if you go to the DynamoDB tables in production and look at the record, you will find like 10 to 12 fields are encrypted.
And I will say there was some negotiation.
And there was some.
Were there specific compliance mandates you have to adhere to, or was it just generally, hey,
So we went through the security scan that Amtrak has in place. So yes, we worked with their security team and we got their go-ahead. It was new to them as well. But given that they had similar policies to encrypt the data at rest, they were able to give us okay. And when the data moved to Redshift was inside their VPC, so we decrypted the data for reporting.
Sure.
Question, you might have brought this up before, but obviously the new operating system has a lot more capability, but if you just look at the operating cost compared to the older system, did you guys do any kind of, I assume you did, how does that per month cost compare to the old system?
So
Thinking about fully loaded, so on-prem facilities and people.
right. So the question, I'm just going to repeat them because I don't know if everybody can hear them, but the question was, what was the comparison of the cost between the analytical platform before and after? The challenge is it's a little bit difficult to do that math, right? Because actually the analytical system before was also the operational system, and so the costs were all mixed. A lot of them weren't broken out cleanly. What I can say, on the other side, from an analytical perspective, there were some reasons that the client elected to reserve a bigger instance for Redshift than was needed for this because of some other things going on. So there's a little bit of apples to oranges. We did look at a lot of the things sort of overall. What I can say is that there is substantive cost savings, and I can't say a whole lot more than that. So I'm sorry, you had a question?
yeah, so have you guys had any outages using the AWS Lambda function? And then how, like, basically you guys do, or if you did, how would you guys approach that, and how you guys monitor and try to detect those problems as they happen?
So the question was there any outage and how our system responded during that time frame? So yes.
Well, outage of Lambda functions.
Outage of the Lambda function. No, we didn't experience outage of the Lambda functions. However, there was a service disruption for S3 for, I think, 20 minutes when we were in production. And given that, so during that time frame, on the upstream side, we had message queues that was able to hold the message. Now, if it would have prolonged for a couple of hours, then we would have run into a problem. One of the things we didn't build, it is a single reason solution. And now we are working to make it multi-reason with proper failover.
You guys have, or what kind of monitoring tools do y'all use to detect those issues? So like you said, if it had gone, if the S3 outage had gone on a little bit longer, you have problems there. How do you guys
App Dynamics, so App Dynamics was connected to all the AWS services, to upstream message queues, to JBoss, to Mule Cloud Hub that runs on AWS, and there was a central dashboard where you can see. So it will start sending notifications if your saves or writes to S3 are failing. It's going to give a tier 1 alert. Go ahead.
Was doing the encryption at rest in Dynamo a big compromise for you guys as far as usage and functionality?
We didn't experience that. So we tested the system for 3 million transactions per day without changing anything on this platform. And it just worked. It's funny because when we were having performance testing conversation with AWS architects, they basically told us you are testing, your workload is like a drop of water in ocean. So go ahead and test it. it's nothing. So, and that's exactly what happened. We just tested with 3 times read capacity. It just worked, and we scaled it down.
I'd also add, just from a reporting perspective, most of the reports don't run on the encrypted fields. So there's a bunch of different things that make it that it's not like we're typically querying on fields that are encrypted.
Yeah, on Redshift, it is not encrypted.
And Redshift's a different story.
Yes, and Tableau server, it runs on the same, it runs on EC3. So the response time was within 2 to 3 seconds to get a report.
Sorry. Did you? Sure.
So awesome. It looks really awesome. And the story is very compelling. Now, as the system scales, are there areas that will require development, like risk areas that you guys think you guys will have to go to? Do you anticipate any?
So the question is, do we anticipate any risk areas as the system scales? Honestly, not at the moment. I think when we get to very different use cases, right? So if we get to people wanting to use some of the transactional and operational data in different ways, that's when we'll have to pay a little bit more attention. But for a lot of the use cases that people are talking about today, including some of the marketing, sort of on-demand marketing and other things, we don't see any problems.
Yep. One of the design practice we used is to not allow direct access to DynamoDB. So we had set of data services to access. So there was no direct access to DynamoDB. You don't need to know how the data is stored. For sales and ticketing data, we are going to merge and take it to a place where I can write data services to give you the data.
Sir.
Sorry, what?
Face challenges in what while coding?
No, I think we...
Debugging? It took some getting used to.
It's a normal debugging. Our language was Java, and you kind of look at CloudWatch log for errors. It's not very different than any code you write and debug.
Yeah, I think that's a glib answer. It took some getting used to. How's that?
Yes.
Right? Because you don't necessarily have access to all of the tools that people have become accustomed to. You have to go back a little bit in time to remember, for those of us who used to debug things from log files, it's a little bit more like that and a little bit less sort of, debugger in the system when you're trying to test out what's running in Lambda. But it's a habit. Some of us still remember that stuff. Sorry.
So why did you guys choose to go to NoSQL database?
So why NoSQL? Funny. Actually, because as it turns out, although you might think that tickets come off the mainframe in a structured format, it actually turns out that ticket formats vary wildly based on the nature of the ticket. If you have a group ticket, it looks nothing like if you have a regular booking and ticket, and that looks nothing like some of the other sort of some of the other borderline cases that have been developed over 20 or 30 years. And so as a result, it's not as clean. And that actually made it easier to map into NoSQL.
And two very complex relational data model with 25 tables in each. We kind of converted all of that in single record, correct? Because you kind of roll up and store in a JSON file as a single record, and then you add additional Lambda functions to split the data, to get the data you want, to create data services. It was more efficient, and you don't need any servers.
Okay. Last question? Anybody? Cool. Well, thank you all for your time.
Thank you, everyone.
It was a pleasure talking with you.